Thank you. Thanks for coming to my talk. I'm very honoured and grateful to be talking to you about this. This is a subject close to my heart, and I've been working on this stuff in the background for a number of years now. So I'm going to jump straight in. Firstly, just defining what I'm talking about. What is microtuning? So I define microtuning as any tuning that falls outside of 12-tone equal temperament. And equal temperament has become so all-pervasive in our music making that as generally musicians and composers that I've spoken to, the majority of them aren't really aware of other tuning systems and what they can offer. So what do I mean by microtonal scale? Basically, a musical scale that describes a microtonal tuning. So it can be, it's generally, you just generally see it as a list of cents or ratios or a combination of the two. And each note is described by its distance from the root or the tonic. So here's a super simple scale. It's a just intonation minor triad. And so, for example, if you're 1/1, which is your root or tonic, imagine that's an A at 440 hertz. You'd work out the frequency of the 3/2, which is a fifth, at 660 hertz, and that would give you a beautiful perfect fifth where the harmonics line up. An interesting audio. I should have some audio. It is on, okay. It's because I turned the audio down. Let's try that again. So, one interesting property that you can have with microtonal scales is non-octave repeating scales. So with this scale I'm showing here, if you imagine that it repeats at the fifth, at the 3/2, that's a scale going up. And scales like this like that scale, although it sounds like it doesn't sound that unusual, but with scales like that, they will fall outside of the octave pattern. If you want to be explicit about it repeating at the octave, you would usually add a 2/1 at the end. So that's the same scale, but repeating on the octave. I'm going to give you, just for a bit of context, a couple of examples of microtonal music. This piece is by a guy called Robert Rich, who co-created the MIDI tuning standard in the 90s. And this is a track by a guy called Sevish, who's really active in the microtonal music making world. He's got a blog, and he's also created a very cool tool called Scale Workshop, a web-based tool for designing and editing scales. So, why am I giving this talk? Well, rewind to about 6 years ago. I'd heard about just intonation from someone, and I started researching it, and I found this book called The Just Intonation Primer by a guy called David Doty. It's a great book, highly recommend it. So I started reading this book, and I was getting really into the ideas and the theory. I was like, yeah, I'm starting to get this. Okay, I want to start making music with this stuff. So I didn't really know where to start. So I went on YouTube, and I found a video by a guy who was showing how you can use absinthe you can retune all the notes in absinthe using you don't put the ratios in, but you put the decimal result of the ratios to create kind of a just intonation scale or whatever kind of scale you want. So there's the tuning area. So this is the track that I ended up making, coming in the background. So I had this nice pad sound going on. I was happy with that, but I wanted to add a bass line to my tune. At the time, I had a modular synth, and I had this ES3 module, and I found that with a Python script, I could send some calibration data to this module to retune it. Okay, cool, I'm happy with that. I'm a programmer, I can deal with that. But I started seeing, so for the average musician, they might not be too happy about that. Next, I had a hardware synth, a MIDI synth that didn't support MIDI tuning standard. And I found this open source program called Mutabor, which allowed, with its own kind of language, allowed me to describe a similar scale that I could use in my track, and it uses the classic pitch bend trick to retune the synth that way. But as you might imagine, I had a few moments like this. Very frustrated, I was being taken out of my flow. I just wanted to make music, and it was a very different experience to what I was used to, not having to think about tuning. So this kind of led me to where I am now. But I was just thinking, there's got to be a better way. So I'm going to digress a little bit from this story and give you an overview of the current support for microtonal scales in software and hardware. So Bitwig have just announced a new built-in device called MicroPitch, which allows you to import Scala files and retune a 12-note scale according to that Scala file. Logic has had support for retuning for quite a long time, but it's limited to its own internal instruments and also limited to 12-note scales. Cubase also similar to Logic with internal instruments only. And we've got Scala's quite famous. It's a great tool, but not that user-friendly in my opinion. It's free and open source, allows you to edit and manage scales. Scale Workshop is created by a guy by Sevish, whose music I played earlier, which is a really useful tool. And I also used it to create the little examples earlier on. There's a company called HPI, I think you pronounce it. They create various software and hardware for retuning instruments, including a little MIDI device. There seems to be more and more hardware manufacturers that are supporting retuning. Tubutech make a cool little Eurorack module which takes an SD card where it can load Scala files. But most of the others rely on the MIDI tuning standard to load scales into their synths. And again, with software synth developers, more and more seem to be adding support for loading tunings into their synths. I want to give a special mention to some stuff that's happening in the iOS world. There's an app called Wilsonic that's been around for a while, which is a really nice tool for playing with different kinds of scales and allows you to export them as well. And the developer, who's called Marcus Hobbs, is now part of the Audio Kit team, and he's integrated some of the stuff from Wilsonic into the amazing free Synth 1 and also the D1 synth. And they've created this cool feature called TuneUp, which allows you to share scales between iOS apps. So yeah, I want to give a shout out to Marcus Hobbs for his work on that. I'm going to just give a really brief overview of some of the main file formats and tuning standards. So the first one is a MIDI tuning standard created by Robert Rich and Carter Scholes in the early 90s. It's pretty precise. It's really flexible with kind of tunings. and has quite a lot of support in hardware and software synths. Unfortunately, it's not human readable because it's just a MIDI data dump. And you've got the tune format, which is human readable, and it's a nice format because it combines the description of the scale with how it's mapped across a MIDI controller. And we have the very now ubiquitous Scala format, which actually comes in two parts: the SCL file, which describes the scale, and the KBM file, which it describes the keyboard mapping. And you really need both of them, and you need them to be properly implemented in order to have full flexibility of how you use a microtonal scale in a composition. There are other formats. Absinthe has its own proprietary format. You can import scripts into Kontakt to retune them as well, and there's probably some others which I won't go into now. So what I've talked about just there is where the responsibility for tuning is within the instrument itself. It's also possible for a DAW or host, or even some kind of MIDI processing device to retune an instrument, usually using pitch bend, either on its own or within the context of MPE. MPE makes this much easier because you can do it polyphonically without having to have multiple copies of the synth on different channels. It does have some limitations. It's sort of reliant on the pitch bend implementation in the synth to be accurate and high resolution enough. There's another issue that can crop up for users, is that some plugins allow you to load the scale from anywhere on your hard drive. Others restrict you to where you can load the scales from. So if you're kind of building up a scale library, you're going to run into duplication issues, and it can be an issue. So I'm going to just have a sip of water first. So going back to my story and my frustration, as often happens, it's necessity is the mother of invention. Through my frustration and feeling like this could be better, and I also understand now that I maybe wasn't using the best tools. I just used what I could find at the time, and there are better tools around now. But even so, it's a very fragmented world if you want to be making microtonal music. So my vision was that, say, you could have a tuning app to tune physical instruments. You can have a plugin with the same scale. You could have a hardware synth with the same scale, and somewhere to manage all these scales, where all the scales are in one place and they can be shared between apps and across devices. And I was just like, I was a web developer at the time, and I was learning about some new technologies, one of which is called CouchDB, which allows auto-syncing, and there's some library that you can have on a mobile device that allowed auto-syncing of this data, and I was like, okay, that might be a way forward. So there's a picture of how someone might look happy that they can make microtonal music easily. So my proposed solution consisted of a shared scale database that should be accessible from any audio software, from plugins, from mobile apps, and from the web. So in order to make this possible, I kind of basically altered the Scala file format into a JSON-based format. And what I also wanted to create was a cross-platform SDK, which, say, a C++ developer would be able to just drop into their project, maybe, add some settings and go. So I've talked about all these different formats and how fragmented things are, and here I am talking about another format. So you might have seen this cartoon before. So yeah, I'm considering adding a new format into this already fragmented world. What am I doing? Well, I would say this format isn't great for sharing files. This is more aimed at JSON database storage. So here's an example, a simple example of the scale I showed at the beginning of how it might be represented in this format. And so you have an ID, so the ID is unique within each database, and you have your description, root frequency, notes, and the nice thing about JSON is it's extendable. You can add new things without breaking it. So I'm calling it Tonal DB, and the main aspect of it is that it's cross-platform. As I mentioned, I wanted to have a C++ interface, and I'm also going to make it available for iOS developers, possibly Android developers as well. It's going to auto syncs with the remote database. That's because of the libraries I'm using. That's what they're good for. So the idea is that, say, a user is creating a scale on a mobile app, that when they look at a plugin using the same system, that new scale they've just created, if they're connected to the internet, would just pop up there. And there's also a shared local database. So on desktop platforms, it would be one location on the hard drive where the database exists, so that it's accessible from various different plugins and apps. This wouldn't work on iOS and Android because of the sandboxing, so there might be some duplication, but those devices are often online, so it shouldn't be a problem. I want it to be open source, I want it to be accessible, and liberally licensed as well. So the way I'm seeing how it might look and how I'm building it in an app I'm working on at the moment is splitting it into two, really. There's like a public database, public scale database, where users can browse lots of scales, and they'll have their own database. So each user in the system, and they might be identified by their email address or a username, each user has their own personal database where they can edit scales and share them with other users. So when they hit share, it might get added to another user's database. So one of my visions early on when I was thinking about this was, say I'm a composer or I'm in a band and I want to use this scale. I'm like, okay, I've come up with this scale, and say I've got like a violinist or a cellist or something, and I want them to play something in this scale, like I could just say, hey, just download this app and I'm going to share this scale with you, and off you go. So I'm trying to take microtonality into the modern age, so away from this sort of sharing files of different formats into something more unified, and with data in the cloud that's auto syncing that we're kind of used to with like things like Google Docs, etc. So a bit about the stack that I'm using. So on the server is CouchDB. I've chosen CouchDB because it's lightweight, it's cheap to run, and on the devices is Couchbase Lite. Couchbase Lite basically speaks to a CouchDB database, and it handles all the auto-syncing stuff. So a lot of the legwork has already been done. And Couchbase Lite is also very liberally licensed, so it can be redistributed without problems. This is some code from a little test plugin that I wrote, just a proof of concept. So the example I'm showing here is it's setting up a vector of, this is some juice code you might recognize, the var object, which can represent JSON. And it's given a name of the database. The actual the server and username and password details are hidden in a file that's ideally not committed to a repository. And then there's two methods here. The first one pulls the scales down from the database, and the second one shows scales as they come in. So it's setting up a lambda function, which you could use that to display your list of scales in a list somewhere in your app. And it doesn't actually need new scales to trigger it. The first time you run it, it will call this function. So that's kind of how the API I'm sketching out at the moment looks. And I'm just going to finish with some words about what the future might look like in terms of microtonal support. And the most exciting thing at the moment is MIDI 2.0. If any of you were in the talk yesterday, you would have heard some of the things, but basically it allows direct control of pitch from outside of the instrument, which in my opinion is where it really belongs. I don't think it should be the responsibility of the instrument itself to do the retuning. Ideally, that's done from outside the instrument. So MIDI 2.0 allows super fine control of the tuning. Another thing that I'm personally interested in is distributed data. So I would, at some point, I think it would be cool to use a system like IPFS, Interplanetary File System, which is a distributed data system, a bit like torrents. So rather than having the scales on one database that someone needs to pay for and manage, the scale data could be distributed across the world. So yeah, that's what I wanted to tell you about. Thank you for listening. So I think there's time for a few questions, if anyone has any.
Hey, I was wondering more generally if someone was interested in making music with microtonal scales and has no idea where to start, like, how do you get started? Because I imagine some of them sound pretty weird. Like, how would you start if you know how to play with normal notes?
I would recommend reading up on it. Yeah, there's that book I mentioned by David Doty was, for me, a really good introduction to the theory about, that's more about just intonation. And something I didn't mention is there's another, so the two main types of scales are just intonation, which I've talked about, and also what's called EDO scales, which are equal distance per octave, or equal divisions of the octave scales. And they're quite popular because they're more common. They have more commonality with what we're used to in terms of equal temperament, because they basically split the octave up but into different numbers of divisions. So some of them share similar properties.
So would you start with something like that, which is more closely related to what we already know, and then you can get into the more esoteric stuff? Or I don't know.
Yeah.
And then one other thing actually I'm wondering is, like, so then when you play your keyboard, you're just playing different notes essentially. Do all these scales have 12 notes in them, or some of them? Okay.
They can have an arbitrary number of notes.
Okay.
And they can repeat, like as I said, they don't have to repeat at the octave. So you can get.
So is it something where, like, a traditional keyboard piano layout that doesn't necessarily make that much sense, and actually a grid controller or something is
exactly that can be so it's an opportunity for completely new musical interfaces as well, which is also interesting for me.
I'm definitely going to try it. Thanks.
Hello, thanks. Maybe a little pedantic, but I'm curious your perspective. Do you think there's maybe a better name for microtonal? Like, what about scales that are more like macro? Like, there's like bigger gaps between the notes than a 12-tone scale.
Good point. Yeah, I don't know. Maybe there is a better name, but I haven't thought of it yet.
Thanks.
Thank you very much. I found this really interesting. I'm curious, maybe I missed this during the talk, but what state is the project in?
Thanks for asking that. Yeah, I forgot to mention that. So the state it's still in kind of like proof of concept stage at the moment, but anyone who's interested in either like using it at some point or getting involved, I'm open for people to come and help. For collaborators, there is a repository on GitLab, which it's not private, but it's not an open repository, so I'm happy to send whoever's interested a link. It's just not quite ready for to be completely public. So yeah, it's I've got a proof of concept, like I showed. I've got a Juice plugin that pulls data down that can share the scale data with a mobile app. So I've got that bit working.
Thank you.
Anyone else? No? Cool. All right. Thank you very much.